with Jack Dangara. We're going to talk a bit about the HPCG benchmark. I'm going to give a bit of a technical overview of it, some of the status of the work that's gone on recently, and then Jack will get up and give you all the information that you really care about. So, all right, so let's get started. Just to give you a brief sense of what it is, unlike the High Performance LinPack benchmark, which is used for the top 500 ranking, which is dense linear algebra, this is sparse linear algebra. It's iterative versus direct. It's a synthetic system, and it tests a lot of features that aren't tested by HPL and have some merit for problems that many people care about in the area of partial differential equations and data analytics and similar kinds of application domains. The model problem is a synthetic structured grid, but stored unstructured and treated that way, and so the impact it can have is on a variety of problems. Some of the merits things that we tried to go after with this benchmark are listed here. I'm not going to go into them in details. Really what we're after with HPL and HPCG, what we would like to propose as we go forward, is that we put HPL and HPCG as bookends of a spectrum, a performance spectrum. HPL provides you with a very high value in gigaflops, petaflops. HPCG gives you a very low number, and between those two is very likely an application's performance potential. And in fact, if you have those the pair of numbers, it can perhaps help you calibrate how a particular system, if you have those two numbers for a particular system, it can perhaps help you calibrate where your application performance will be. And the closer those two values are, the more, in some sense, the more balanced the system is, at least for the domain of applications that HPCG represents. So a bit of a status. So one effort we went through with some of the vendors who care about this benchmark is we wrote some papers, and these will be coming out in the next few months in the International Journal of High Performance Computing Applications. We're going to have a reference HPCG paper. We're also going to have a paper written by benchmarkers at Intel, NVIDIA, NUDT, Riken, and then coming a little later is a paper from IBM. And these papers discuss the optimization strategies and the results and insights that these people obtained by trying to optimize this benchmark for their platforms. I'm going to highlight just a few of these. These are snapshots from the papers that will be appearing in the next couple of months, just to give you some sense of the insight that we've been able to get. So this is a quote from the Intel HPCG paper, and this shows that for Edison, very nice balanced system in my opinion, spends about a little less than 2% of its time in the all-reduced portion of HPCG, whereas other systems listed here have much higher percentages. And so the conjecture on the part of the Intel benchmarkers is that this is due to the very nice network that Edison has. There's also another quote from this paper in terms of collectives futures, and they say even though you have this nice high quality network on Edison, they look at future network designs and see that this will still be a very challenging aspect of the HPCG benchmark, and will push vendors, we hope, to pay attention to this particular communication and computational signature. An impact on broader sets, Intel has also taken the efforts that they put into this benchmark and they're folding them back into their product line, which is again something that we really want to do. HPL out of the box runs quite well because the kernels that were needed to make the LinPack benchmark run well have been integrated into our software system. The BLAs, for example, in particular, run very well. And so because of that, everybody benefits from that performance improvement, and we expect to see the same thing as the HPCG benchmark is that the efforts are integrated into the software stack that everyone gets to use. Looking toward next generation memories, there are very interesting memory technologies and architectures coming along in the near future, and we look forward to trying to explore those and benchmark those with this particular effort. We talk about reproducibility and the variations that come and the kind of headaches that brings to people who are working in this industry. And so this benchmark also provides, because it repeats many executions of the same computation, an ability to monitor variations in results. The vendor efforts have resulted in very large improvements, especially in on-node performance, especially for threaded, fine-grained, data-driven parallelism, which is something many, many people care about. And so this effort has led to a very large increase in performance improvement. It also takes away some of the notion that this is just a local thing that you only need to do, that communication doesn't matter. When you improve the single node performance like this, it really then brings the network much more into it. Okay, the next, and we think last major version of HPCG 3.0 will introduce some more integer and address calculations as we incorporate the problem setup phase into the time portion of the code. And just to give you some insight into what that might mean, if you look at the left box right there, that's the profile that comes from the Alinea profile for the setup phase, and you can see how it's quite different from what the computational phase would be. So we look forward to that. Some just last minute items. The reference version of HPCG is on GitHub. We have a mail list if you'd like to subscribe. We have our next event at SC15 and have proposed a BOF for that event. And so just a bit of a summary. So HPCG is addressing some of the goals, at least to our satisfaction. We had hoped for 50 systems. We seem well on track to achieve that and even more. The biggest challenges we face is we need the community who's looking at performance analysis to be patient and not make premature conclusions. There's a lot of work that has to get done before we can decide whether or not this is a good community benchmark. And anyway, I would like to see HPL and HPCG make a nice set of bookends, and I would love if someone has a wood router to make me a pair. I would love that. Thank you. All right, and then Jack is going to get up here and talk about the range.